Welcome to Learn Yourself. Let us understand these questions which are based on median and altitude. Let us take first question. How many medians can a triangle have? So as we have discussed earlier, if this is a triangle, then each triangle will have 3 medians. From vertex to the opposite side, from the vertex to the opposite side, and from the vertex to the opposite side. So each triangle will have 3 median. If we will see here, how many medians are there? AE, next is BG, and next is CF. So 3 medians will be there for each and every triangle. Our second question, does a median lie only in interior of triangle? If you think that this is not true, draw a figure to show such case. So yes, median will be in interior region of the triangle because median will connect, as you can see here in the note, that median will connect vertex and midpoint of the opposite side. So it cannot be in the exterior region, it will be always in the interior region of the triangle. So as median connects vertex and midpoint of opposite side, it will be always in interior region of a triangle and not to the exterior region. So here also we can draw the same diagram like this, and we can show that with this diagram we can support our comment. Now let us understand some of the questions based on altitude. So first question is, how many altitudes can a triangle have? So here I have shown you one figure. Let us take this as triangle A, B and C. And we have here 3 altitudes. For vertex A, the AE is an altitude. For vertex B, the BG is an altitude. For vertex C, the CD will be an altitude. So 3 altitudes will be there for a triangle. So our answer here is 3. Question number 2. Draw rough sketches of altitude from A, that is vertex, to BC, that is line segment, for the following triangles. We have acute angle triangle, right angle triangle and obtuse angle. So what is an altitude? An altitude has a one endpoint at a vertex of a triangle and other on the line containing opposite side. So here vertex is going to be A and opposite side line segment will be BC. So we have to draw altitude from A vertex to BC line segment. Now altitude will be always a straight line. So it will going to make a right angle at opposite side. This is important characteristic of altitude that you have to remember, that once it is coming out from the vertex, it is touching the opposite side and there it is making right angle because altitude is always a straight line. Now let us go back to our numerical. For acute angle triangle, from vertex A, it has to join the opposite line segment BC and here it will make a right angle. So this we are giving a name, that is AE. So AE will be our altitude for acute angle triangle. Now right angle triangle. Now for right angle triangle, as we can see, from A the line is passing and it is touching the line segment BC and this is right angle. So AC line, that is of triangle, is itself an altitude for right angle triangle. So AC here is an altitude for right angle triangle. It is on the triangle. Now for obtuse angle triangle, we have to extend this line segment, that is BC, and we can draw a straight line coming out of the vertex A and that is going to make a right angle at BC. So AE here is an altitude for obtuse angle triangle. Now here if you will see, for acute angle triangle the altitude is inside. Now for right angle triangle it is on the triangle. And for the obtuse angle triangle it is outside the triangle. So this will be our answer. For acute angle triangle, AE will be an altitude. For right angle triangle, AC will be an altitude. And for obtuse angle triangle, the AD will be an altitude. Question number 3. Will an altitude always lie in the interior of a triangle? If you think that this need not be true, draw a rough sketch to show such a case. So here I have shown 6 different triangles based on angle: acute angle triangle, right angle triangle, obtuse angle triangle. Based on sides, equilateral, isosceles and scalene triangles are there. So let us take first case. In acute angle triangle, as we can see, the AE is an altitude and it is inside the triangle. It is in interior region of the triangle. So one of our answer will be acute angle triangle because an altitude is inside the triangle. Now our second case is right angle triangle. So here altitude is side itself, that is AC. So AC is on the triangle. It is not in the interior region of the triangle. Now for obtuse angle triangle, AD is our altitude and which is outside the triangle. Now our fourth case is equilateral triangle. Here it is in the interior region of the triangle. For isosceles also it is in the interior region of the triangle, and for scalene also it is in the interior region of the triangle. So we can mention here the acute angle, and we can also mention here equilateral, isosceles and scalene triangle, that their altitudes will be in the interior region of the triangle. Fourth numerical. Can you think of a triangle in which two altitudes of triangle are two of its sides? So first case is acute angle triangle. So here from vertex A till BC it is an altitude and it is not the side. For second case it is right angle triangle. Here as you can see the line is coming from the vertex A touching the line segment BC, and it is on the triangle and it is itself, it is a side of a triangle. So here the first side AC is an altitude of a triangle and other side, that is BC, is also an altitude of a triangle, because here it is coming out of B and it is touching the line segment AC. This vertical line, if we will extend, then it is touching the line segment AC. So it is making right angle over here. So BC is also an altitude. So here two altitudes are there. Other than hypotenuse, the two sides will be an altitude for the right angle triangle. So AC and BC, they both will be the altitude for right angle triangle. Now for obtuse angle triangle, AD will be the altitude for the triangle and it will be outside the triangle. So for equilateral triangle, isosceles triangle and scalene triangle, the line will be in the interior region of the triangle and none of their sides will be an altitude. So our answer is right angle triangle, where two of its sides other than hypotenuse will be the altitudes for this triangle. Fifth question is, can the altitude and median be same for a triangle? So we have to check for each and every case of the triangle, that equilateral triangle, isosceles triangle, scalene triangle, acute angle, right angle and obtuse angle. So here I have shown altitude for each and every triangle. For equilateral triangle, yes, altitude and median will be same because all sides are same here. So for equilateral triangle only, the altitude and median will be same. You can see in isosceles triangle, as you can see here in this case, that median and altitude is not same. This is not a midpoint of opposite sides. So altitude and median are not same in isosceles. Then in scalene triangle, median and altitude here also will not be the same. As you can see, if from this vertex, if I'll draw a straight line, then it will go till here, and it is not connecting the midpoint of opposite side. So this case also, In this case also the median and altitude will not be same. Then acute angle triangle. As you can see, this is not a midpoint. So in this case also the median and altitude will not be same in acute angle. In right angle triangle, the side itself will be the altitude. So in this case also it is not the case. The altitude and median will not be same. In obtuse angle, the altitude will lie in the exterior region of the triangle. So median and altitude will not be same in obtuse angle triangle. So we have only here equilateral triangle in which the median and altitude will be same. Think, discuss and write based on exterior angles concept. First question is, exterior angles can be formed for a triangle in many ways. Three of them are shown here. So here this is the first exterior angle, second and third exterior angle they have shown. These are the ways to form exterior angles. Now there are three more ways of getting exterior angles. Try to produce those rough sketches. Now let us first understand what are the exterior angles and how can we form. So this is a figure. Now if I'll make triangle ABC like this and I have extended each and every line segment like this. If I'll talk about line segment AB, then I have extended like this. So with this line segment, this is the first exterior angle. So this is first exterior angle. Same way, when AC line segment I will extend like this, then my second exterior angle will be like this. Now this is not exterior angle. So with vertex A, I got two exterior angle 1 and exterior angle 2. Similarly, at vertex B, if I will extend line segment AB like this, then I will get third exterior angle like this. This is my third exterior angle. At the same vertex B, if I'll extend line segment BC like this, then I will get the fourth exterior angle. And this is not exterior angle. Now with vertex C, if I'll extend line segment AC like this, then I will get fifth exterior angle. And if I'll extend line segment BC like this, then I will get my sixth exterior angle like this. And this is not exterior angle. So at each and every vertex, I will get two exterior angle when I will extend those particular line segment. Going back to our question, that here they have shown us exterior angle. So if I want to draw at the same vertex, then I have to extend this line segment and I am drawing exterior angle over here. So this is one type of exterior angle at the same vertex. If I want to draw with the same line segment and I will extend that line segment, then I'm going to draw another exterior angle over here, and that is now here if I'll extend the same line segment on other side, then this is going to be my exterior angle. So exterior angle 1, 2 and 3. Our second question, are the exterior angles formed at each vertex of a triangle equal? So let us first draw all the exterior angles. So this is my triangle A, B and C. As we have discussed earlier, this is my first exterior angle, angle 1. This is second, third, fourth, fifth and sixth. The exterior angle 1 is going to be equal to the addition of angle B and angle C. So two interior angle, if we are talking about this angle, angle B and angle C, then these two angles summation will be equal to the exterior angle 1. And similarly, the angle exterior angle 2 will also be equal to the B and C. Why is it so? Because angle 1 and angle 2, they both are going to be equal because they are vertically opposite angles. So these are the relationship between the interior angles and exterior angle. Now because of this, Angle 1 and angle 2 are equal, angle 3 and angle 4 are equal, angle 5 and angle 6 are equal. And similarly, if we are talking about angle 3, then exterior angle 3 is going to be equal to the summation of angle A and angle C. So when we are adding angle A and angle C's measure, it is going to be equal to angle 3. But all the exterior angles are not equal. These are the vertically opposite angles and they are equal to each other, but all the exterior angles are not equal. Our third question is, what can you say about the sum of exterior angle of a triangle and its adjacent interior angle? Now let us first understand which two angles they are talking about. So in the figure 1, let us take this triangle ABC and the sum of exterior angle. So if I am going to take, so sum of exterior angle of a triangle. So if my exterior angle is this, I am denoting that angle with E, that is exterior angle of a triangle, and its adjacent interior angle. Its adjacent interior angle is this. This is an interior angle and it is adjacent to that. So this is going to be interior angle. So I am denoting that with I. That angle is interior angle. So what will be the sum of these two angles? As you can see, they are forming a linear pair. They are angles on the straight line. So sum of these two angles will be equal to 180 degree. Let us check that example with second figure also. That here if we are talking about this angle, and let us take exterior angle over here. So if we are talking about these two angles are also formed on straight line. They are also making a linear pair. So addition of these two angles will also be equal to 180 degree. Similarly with this case also, we can check that if opposite side we are taking this exterior angle and this is going to be interior angle, then addition of this two angle will be equal to 180 degree. Think, discuss and write. Question 1. What can you say about each of the interior opposite angles when the exterior angle is right angle, obtuse angle and acute angle? So first we are taking right angle. So if exterior angle is a right angle, what can we say about interior opposite angle? Now if we will imagine this as triangle ABC, which is right angle, and here our exterior angle is 90 degree right angle. You can also take this angle, which is also 90 degree, exterior angle is 90 degree. Now interior opposite angles are angle A and angle C. Now we know that exterior angle, this angle I am denoting with 1. So exterior angle 1. Now this is a property of exterior angle, that exterior angle 1 equals to sum of the interior opposite angles. So if angle 1's measure is 90 degree, then it will be equal to the sum of interior opposite angles, that is angle A plus angle C. Now we know that angle 1's measure is 90 degree, that we have taken right angle as they have said in the question. So 90 degree will be the total sum of angle A plus angle C. When angle A and angle C's sum is 90 degree, they both are acute angle. So our answer is acute angle. So if addition of these two angles should not be more than 90 degree and should not be less than 90 degree, then they both will be less than 90 degree. Then only their sum will be equal to 90 degree. Now let us take a second case, that is if exterior angle is obtuse angle. Then what about interior opposite angle? So here we are going to discuss three cases for that. Case 1, case 2 and case 3. So there will be three possibilities for this case. Our exterior angle is obtuse angle. So this is our obtuse angle, that is exterior angle. Then interior opposite angle. So we are going to talk about these two angles. So A, B and C. So angle A will be acute angle and angle B will be right angle. So this is first possibility. Now second possibility is if our exterior angle is obtuse, then opposite angles. So we are talking about this two angle. So in triangle ABC, so interior opposite angle A and B. So A can be acute angle and B can also be acute angle. Now for the possibility 3. In our triangle A, B and C, if this is our exterior angle which is obtuse, then angle A and angle B interior angle, then angle A will be obtuse which is greater than 90 degree and angle B can be acute angle. So here based on which property we are talking about, that exterior angle, if I am denoting this exterior obtuse exterior angle as angle E, then angle E is going to be equal to the summation of angle A and angle B. So if angle E is greater than 90 degree, then summation of angle A and B will also be greater than 90 degree. Now when we are talking about greater than 90 degree, then there are three possibilities, that one can be right angle, acute angle. In second possibility, both can be acute angle like 60 degree, 60 degree. And in third possibility, one can be obtuse angle like 92 degree or 93 degree. And the second one will be acute angle, so less than 90 degree. So all these three possibilities can be there when the exterior angle will be obtuse angle. Now we are talking about third option, that is acute angle. So if our exterior angle is acute angle, then interior opposite angle will be. So in triangle ABC, our interior opposite angles are A and B. If our exterior angle E is acute angle, that means angle E equals to addition of angle A plus angle B. This is based on exterior angle property. So if angle E is acute angle, that means it is less than 90 degree. The measure of angle E is less than 90 degree, then angle A and angle B's addition also will be less than 90 degree. That means there is only one possibility, is that both of these angles will be acute angle. Our second question is, can exterior angle of triangle be a straight angle? Now what is the meaning of straight angle? Straight angle is something like this, which has a measure of 180 degree. So this is a straight angle. If we are talking about this exterior angle or this exterior angle, to be an angle it has to be less than 180 degree. If it is 180 degree or straight angle, then it cannot be an angle. So if it is a straight angle, if it has a 180 degree measure, then there won't be any angle. Think, discuss and write. Our first question is, can you have triangle with two right angles? All these three questions are based on angle sum property of the triangle. Now first of all, what is angle sum property of a triangle? Then triangles, all three angles addition will be 180 degree. So when we are adding the measures of all the three angles of the triangle, it should be 180 degree and not more than or less than 180 degree. Based on this property, we are going to answer all these questions. So first question is, can you have a triangle with two right angles? Now right angles measure is 90 degree. Now if we are having two right angles in one triangle, for example angle A and angle B, both are having 90 degree, then addition of both of this angle will be 180 degree. Then what will be the measure of angle C? So any triangle cannot have two right angles. Only one right angle can be possible in a triangle. Our second question, can you have a triangle with two obtuse angle? Now what is obtuse angle? Obtuse angle is measure of the angle will be greater than 90 degree. Now two obtuse angle means if the angles are more than 90 degree, for example, angle A is 91 degree and angle B is also 91 degree, then addition of this two angle will be more than 180 degree. So that is not going to possible when we are talking about angle sum properties. So two obtuse angle is also not possible in a triangle. Then third question, can you have a triangle with two acute angles? Now, what is an acute angle? Acute angle is measure of the angle will be less than 90 degree. So yes, any triangle can have two acute angles, because if we are guessing that angle A equals to 70 degree, which is acute, angle B equals to 60 degree, then addition of this two angle will be 130 degrees. So still we can have some measures for angle C, and that will make sum of all the angles will be equal to 180 degrees. So any triangle can have two acute angles in that. Two acute angles can be possible in a triangle. Our fourth question is, can you have a triangle with all the three angles greater than 60 degree? No, because when we will divide 180 degree with 3, we will only get 60 degree. Maximum possibility for all the three angles to be similar. Now if we are drawing the triangle like this, in which the measure of the angles are similar, that means angle A equals to angle B equals to angle C. So what can be the maximum measure of these three angles when they are similar? So for that we need to divide this 180 degree with 3, because we know that all the three angles addition should be 180 degree. So this gives us 60 degree when we will divide this. That means when all the angles measure possible for all the angle is 60 degree. This is the maximum possible measure when all the three angles are similar. It cannot be more than 60 degree. Our fifth question. Can you have a triangle with all the three angles equals to 60 degree? So yes, all the three angles can be equals to 60 degree if this is our triangle A, B and C. If we are adding them, then it will give us 180 degree. So yes, it is possible. Sixth question is, can you have a triangle with all the three angles less than 60 degree? So no, it is not possible, because when we will divide 180 degree with 3, because we have 3 angles in a triangle, then we will get 60 degree. If we are taking measure less than 60 degree, for example, and in that the total will not be 180 degree. So according to the angle sum property, this is not possible. So let us assume this case in which one angle is less than 60 degree. Then in that case, if one angle is 40 degree, then other angle has to be 80 degree. And then the third angle can be 60 degree. So if one angle is less than 60 degree, then other angle should be more than 60 degree. Then only the total for all these three angles will be 180 degree. And then only it is according to the angle sum property. But all the three angles cannot be lesser than 60 degree. Discuss and write. First question is the sum of any two angles of triangle always greater than the third angle? That means if we are adding two angles, for example, if this is our triangle A, B and C. If we are adding a measure of angle A and angle B, will it be always greater than angle C or not? That we have to check. So answer is no. The sum of any two angles of triangle is not always greater than the third angle. Let us take this for example. Angle A is 40 degree. Angle B is also acute and that is 40 degree. Now if if we are taking these two measures for angle A and angle B, then what will be the measure of angle C? So with angle sum property we can do this, that angle A, B and C should be equal to 180 degree. We have 40 degree and 40 degree measures for angle A and B. So angle C will be equal to 100 degree. Now you can see that even though we are adding these two angles, we will get here 80 degree. Whereas here for angle C, it is 100 degree. So it is not greater than the third angle. So it is not always true that the sum of any two angles of triangle is always greater than the third angle. Discuss and write. First question, which is the longest side in triangle PQR right angled at P? So we have to make this right angle and we have to denote it with P because they have specifically said that it is right angled at P. Now it has to be PQR. So P, Q and R. Anti-clockwise I have given the names and it is PQR. We can also give the name like PQR like this, and which is going to be clockwise. Only thing we have to make sure that it should be right angled at P. Now next, which is the longest side in triangle PQR? So whenever the triangle is right angle triangle, the hypotenuse side will be the longest side for that triangle. Our next question, which is the longest side in triangle ABC? So let us denote that A, B and C and right angled at B. So our B should be at right angle, its measure should be 90 degree. So ABC. Now which will be the longest side? So here AC will be the longest side for this triangle ABC. Third question, which is the longest side of right angle? So any right angle triangle if we are taking, which will be the longest side? So again the answer will remain same, that this hypotenuse side will be the longest side for any right angle triangle. Our next question is, the diagonal of a rectangle produced by itself the same area as produced by its length and breadth. This is Bodhayan theorem. Compare it with the Pythagoras property. So let us first understand the Bodhayan theorem, and it is with respect to rectangle. So here this is our rectangle, that A, B, C and D. If we are denoting this with length and breadth, then let us have here A will be the breadth, B will be the length, and here E will be the length of diagonal AC. AC is diagonal here. Now let us understand the statement for Bodhayan theorem. The diagonal of a rectangle produced by itself the same area as produced by its length and breadth. So from the Bodhayan theorem we can write here that E square equals to A square plus B square. Now the same thing we can see here in Pythagoras theorem also. If our right angle triangle is ABC, in that we know that this is A, this length is B, and then E will be the hypotenuse. Then we know that according to Pythagoras theorem, E square equals to A square plus B square. So here we can see that Bodhayan theorem and Pythagoras theorems are same, but the Bodhayan theorem is with respect to rectangle, whereas Pythagoras theorem is with respect to right angle triangle. So thank you for watching and learning with us. If you have any doubt, please comment down below. I'll see you in next video. Till then, keep learning, keep sharing, and don't forget to subscribe, learn yourself.